Hello, my name is Victor Schetinger and I will present the paper Deliciousness, Challenges and Opportunities for Visualization in the Age of Generative Models, which I wrote with my co-authors Sara, Mennatallah, Andrew, Matthias, Apolinário, and João. Let's start by talking about what are generative models. If you watched our teaser, you already saw some examples or heard some examples. First, a narration by Snoop Dogg was produced using a text-to-speech model. And the images you see were all made using MidJourney. They're just a few of the hundreds of thousands of millions of images that can be generating, and the possibilities are truly endless with this kind of tool. Even with a simple prompt, you can get infinite variations on a subject. Here are a few examples of the prompts we use for these particular images. So, a 1910s modernist bar chart data visualization. An infographic of microcrystal shapes designed by Paulo. An infographic of pen size designed by Malevich. When you conceived this paper a long time, and 8 months ago, we were concerned mainly with text-to-image or image-to-image technologies and applications, because we thought these are the ones closer to visualization. For instance, asking Stable Diffusion to generate a bar chart made of fruit. At the time it was, and to a certain degree it still is, a challenge to actually put information into the visualization, sort of constrain it to the data. However, a few months after writing our paper, this word came out, vis-to-vis, prompt-driven stylized visualization generation using a diffusion model, and I tackled this challenge. Here on the right, you can see we're using MidJourney into image to combine visualization designs to explore new visualization design spaces. But here, this is a very cool possibility. This was an experiment which I did. While I was at the Museum of Modern Art in Stockholm, I started taking pictures of the art and throwing it into MidJourney using my cell phone. And it was giving me very nice results in semi-real time, right? So I would wait for a minute to get the result. It was really like being able to experience a combinatorial space of the art I was seeing at the museum. And this was really interesting experience. Now that you understand what are we talking about, what are these generative models, what can we do, what are then the motivating questions from our study? We can summarize it as: how will generative technologies and its applications affect visualization research, practice, and fundamentals? What did we do to answer this question? We performed a study with experts where we brainstormed scenarios and assessed them. So they were semi-structured interviews with both open-ended and focused analysis. Open-ended in the sense that we elicited ideas from them in all phases of the study. We talked a lot, so we were collecting many quotes and individual opinions. And focused because our instrumentation methodology allowed us to get objective insight into the different phases of the visualization pipeline. And we had at the end 22 interviewees. 17 were from Viz or HCI, 5 were from art history, or design, and 2 from machine learning. When talking about related work, in the paper we focus mainly on discussing generativeness in visualization, but you can also consider studies with similar surveying goals or methodologies to be related work. We're not exactly doing a star, but it's very similar in some way. Here's a sketch of the methodology we use. We did 1-hour interviews using a mirror board to gather inputs. First, we had an onboarding phase, then we ideated on opportunities, and finally on challenges. We collected their input by recording the interview and by taking the final state of their mirror board. Here's an example of a mirror board from one interviewer. You can find all of them anonymized in our supplemental material. You can see if this person is a visualization expert, a machine learning expert, but you don't know who they are. You can see here the correspondence between the phases here with the color. So the onboarding, the opportunities, and the challenge phases, how it is, let's say, in our sketch, and in how the mirror board looked like. First, we had an onboarding task where we showed many of the examples you saw before to contextualize them. Right, this thing that this talk we just had with some examples we had with the interviewees. Then we had a self-identification phase, which served 2 purposes. First, to capture the subjective background of the person, how they describe themselves, and to introduce them to our answering modality on Miro. So maybe the person never used Miro, need to get used a bit. So our main measure instruments were those planes or orthogonalities on which our subjects had to place and order concepts relative between two axes. So for each phase, the orthogonality was different. We asked them to reshape an oval shape over the space of research versus industry on the y-axis and artistic versus technical on the x-axis. So you can see here there's two possible answers from people. This person considers themselves somewhere between these three big areas, and this other person considers themselves very research and technical oriented. On this next phase, opportunities, we were talking about applications. So in this plane, the second plane you see here, we would characterize applications, and we would then copy the post-its from this plane into the next plane to assess them on different dimensions. So in this way, we have sort of a higher dimensional characterization of the item or concept. The applications were first characterized by their scope. Is this generative models being used in visualization? Then this is gen for vis, up arrow. Is this visualization being used in or for generative models, like visualizing parameter space or something? Vis for gen, the down arrow. So the x-axis is how subjective or artistic is the end goal, like making visualization more aesthetic, or more objective, like synthesizing test data. So this is left versus right. So this plane came already filled with some black post-its, which are applications we, the authors, ideated beforehand and thought that would be a good basis for discussions. Then we prompted the interviewee to add their own ideas to the plane. So in the case a person was not feeling particularly creative or could not come up with interesting ideas on the spot, at least on the next step they would have to rank our baseline applications. And this made sure we get some output from them. On these last two quadrants, they are the most important for a study, where we try to extract forecasts, be they based on expertise or gut feeling. They measure first opportunities for the applications, then challenges of the generative models in visualization. We try to make it really simple. Opportunities are about feasibility versus excitement, and risks are about concern versus likelihood. All this in a broad subjective sense. To make it easier for the onboarding, we decided to name the different quadrants in these planes. And this is where the name of the paper comes from. So deliciousness is, we're talking about delicious low-hanging fruits, which is how we call the quadrant for high excitement and feasibility. So things, applications that are both cool and accessible to do maybe early. So high excitement, low feasibility is wildest dreams. And feasible and unexciting are useless trinkets, and unexciting but feasible are inevitable corporate applications. So things that would come out in the next Office package or the next Adobe package. So on the other plane, the other part of our title, a doomsday prophecy, which is something that is very concerning, but probably won't happen too soon. Something concerning but inevitable is like watching a train wreck. Something inevitable but not concerning is just the way it goes. And finally, something unlikely and concerning is not worth a thought. In terms of risk, of course, you can see that all of them have different fonts. These I made for the presentation. I explained the idea to ChatGPT and gave it the names of the quadrants, asking for adequate font to convey their central idea. Also, I asked ChatGPT to name the planes based on their semantics. So it called the opportunity plane generative frontiers and the challenge plane technological uncertainties, which I thought was very diplomatic. And the fonts I cannot really say if they're adequate. I'm not that good with this sort of design, but it gave me explanations about them, right? So maybe I believe the explanation. For this paper, we also developed this encoding, which summarizes the answers of our subjects to a particular concept. So you can see the average in each individual answer along these dimensions. For the first part, we have four axes because we have two planes. And for the risk, we just have two axes because it's just one plane. And all of the different concepts that were discussed have their encoding. You can find all of them in the paper. They had to be coded by hand from the relative positions of the post-its on Miro. And we sort of superimpose an imaginary grid on them to code them. This is the overview of our methodology. When we did this, after performing this interview with people, what did you get? What were our main results and contributions? So first, I think the methodology itself, I think it's a really cool methodology. Using Miro, using this sort of format was a very interesting experience, and I feel I'm going to use this more to make evaluations in the future. Then we have over 22 hours of coded interviews. They're not public, but we synthesize them. We use author.ai to transcribe into text. Then 3 of us analyze them. We try to identify key ideas and quotes that represented them. So, for example, subject 14 from visualization suggested at one point that everything that is robust is obvious and everything that's obvious is robust. And then we have also another example from subject 16, machine learning expert, saying that bias is a human problem, not a machine problem. And we will see in the paper these quotes being placed where they belong and in the right context, in the right point of discussion. We also have summarized results, so we kind of show where all the different posts fall, where people are answering things, how are really the major behavior of answer, and the detailed results, as we just showed a bit before, these encodings, so that you can really see all the answers there. Also, there's the mirror boards if you really want to see the detailed results of the interviews, with even the posts the person added, links and other things they added. Very importantly, we did this analysis of the VIS pipeline. It's too complicated to go into in this short presentation. But what we did is we used even another type of plane based on SWOT analysis from business. But these are planes that are basically divided into help and harm. And if the help and harm comes from inside, from the visualization design, or from outside, from the application domain. And we went through all the steps of the visualization pipeline and trying to get the data we had from the interviews and place them there and sort of explain what happens here, right? But of course, I feel the most important thing we did was synthesize everything into our main conclusions. Right, so we have a lot of cool main conclusions in the paper, but here in the presentation, I sort of reorganized them based also on more recent discoveries and things that have come out that are not necessary in the paper because it's very hard to follow up. Right, so our first main conclusion was experts were more optimistic than scared, at least in our interview. And remember, this was before ChatGPT had come out. So they were optimistic despite or precisely due to considering many risks inevitable. So, well, is this attitude really healthy? Is it sustainable? We don't really know yet, but there's not enough clarity at the moment. We can be optimistic. On a practical level, most concerns revolve around truthfulness and deception. So visualization is about informing, communicating. And there are many ways that these channels can be hijacked, from generating fake data to psychological manipulation. On a deeper level, however, the concerns from our subjects vary greatly. There were ethical concerns, political, socioeconomic, even in terms of energy consumption and global warming, like how much it costs to train these models. And generally, very philosophical. So existential questions about the nature of reality, consciousness, and freedom were very present. Like, if this is truly AGI, if there are sparks of consciousness, is this going to be the Skynet, or are we the baddies that are going to enslave this intelligence? We don't know. Things are moving very fast. It's hard to determine what is the state of the art at any moment. Even if one had the time to read all the papers that come out on the subject, just on arXiv or everywhere, to go through all the posts, all the commits, and the GitHub repos, watch all the videos and listen to all podcasts, it is not enough. There's not enough time to engage with one of these technologies and experiment and really see what is the state of the art before it changes, before these things is surpassed or outdated, which generally takes a week. If these technologies are here to stay and they become services like the internet, like Google Maps, whoever controls them has immense power. Great responsibility should always come with great power, right? But it's hard to trust that monopolies will not act on their own self-interest. I don't think this is an AI bubble. I think it's much more like foam. So some of areas of applications might be bubble, but there are so many of them that it's not clear when and how they're going to burst. Almost every technical area has been or has the potential to be touched by generative models in some way. Coming back to visualization, when we wrote our paper a long time, 8 months ago, things were looking very different. I showed the paper at the start of this presentation that was the exact implementation of one of our suggested concepts that came out just after we had submitted it, these two areas. So with ChatGPT, many other applications should be doable, right? ChatGPT changed things. Even looking at Hugging Face and all their models there, almost everything that we discussed there is doable somehow with a certain degree of engineering at this point. At the end, is it doom or is it deliciousness? Or kind of both. I want to end with this quote from Whitehead that says, it is a business of the future to be dangerous, and it is among the merits of science that it equips the future for its duties. I would add also to this view of science, it should not only include, but strongly be based on the humanities, because as we can see, the main challenges are not really technical in nature, and we will not be able to solve them through a purely technical approach, right? This is the end of our presentation. Thank you very much for watching, and here's a link to our project page.